YouTube can play pretty much any type of file.
Okay. So
I'm back.
So whenever you guys are ready, I'm good. So if you want to get that, yep.
we are recording right now. Do you see all the Zoom junk on my screen, or just the presentation?
I see the presentation and then the three of us on the right-hand side.
Right.
Okay. Well, it says we're recording, so let's go. I have a 3 o'clock, so
We'll come in hot. Let's get ready.
Yeah,
3,
let's go.
2, 1, here we go. All right, good afternoon. I want to welcome folks to the continuation of Husch Blackwell's Construction Academy Executive Thought Leadership Series. Today, I have the honor of speaking with Adam Arndt of Catalyst Construction and Jason Korb of Korb and Associate Architects about the world's tallest timber tower, say that 10 times fast, set to begin building this summer. Briefly, my name is Eric Meier. I am one of the co-leads of the Husch Blackwell Construction Practice Group based out of Milwaukee, Wisconsin. And about a year ago, I worked with Josh Levy from my office to create the Construction Academy platform to be a place where we could capture thought leadership across the spectrum of the construction and design industry. Since we launched in July of last year, we've had a tremendous response from clients and partners and produced a long list of high quality programs, articles, and other content that you can find on our website. So without further ado, I want to introduce Adam and Jason. Adam is president of Catalyst Construction. Catalyst is a construction management company based in Milwaukee, Wisconsin, but does development and construction work throughout the Midwest. Adam has an engineering degree and an extensive construction background. And a brief fun fact about Adam, he and his wife live in the same 100-year-old house that she grew up in. Jason Korb is the principal architect at Korb and Associates Architects. Korb is a full-service architecture and design firm located in Milwaukee. Jason has a master's in architecture and over 2 decades worth of architecture experience. But more importantly, he used to be a working musician, and back when we could go to Summerfest, is known to have played at Summerfest. So guys, with that introduction out of the way, I want to turn things over to you, Adam, and you, Jason, to talk about the Ascent project that both of you are involved with in downtown Milwaukee. Thanks, guys.
Yeah, thanks, Eric. Jason's going to lead the presentation for the most part and jump into it. He's got probably the most knowledge of anybody in the state of Wisconsin as it relates to timber construction right now. He's traveled the world over talking about this project and just about his knowledge on this. So between our two firms, we've done a heck of a lot of research and have a pretty good baseline on this type of project. And we actually at Catalyst just finished up the first mass timber construction project, Timber Lofts over off of Florida Street. It's a smaller project than this, but we just finished that up. So it's exciting development, kind of exciting where the industry is headed. So Jason, take it away, man.
All right, thank you, Adam. So we're going to start with some precedent studies in terms of what we're currently permitted to do by right and what various people are doing around the world with mass timber. What you're seeing here is the first mass timber building we designed for this client, Newland Enterprises, and it represents what you can do as of right, at least in the state of Wisconsin. We are operating under IBC 2015, so you are allowed 6 stories of heavy timber framing over a 1-story concrete podium, 7 stories, 85-foot height limit. In Canada, currently the tallest mass timber building in North America is Brock Commons, which is 17 stories of timber over a 1-story concrete podium. The stair and elevator cords are cast in place. That was a concession to the code officials in Vancouver. And basically, the way that Brock Commons got approved is that the timber is all wrapped in 3 layers of drywall, which we find to be less than an ideal solution because you can't actually see any exposed timber in this building. The tallest mass timber building permitted in the United States was permitted in the state of Oregon in 2016, And it was also, aside from fire considerations, it's in Portland, Oregon. It was in a high seismic zone. And so we benefited from some of the testing, which we'll jump into a little later, that was performed to get this project approved. And we're going to use some of that methodology on our project. Unfortunately, this project was in part funded by low-income housing tax credits, and it was canceled because the value of those credits sort of went way down at the end of 2017. Currently, the tallest mass timber building in the US is Carbon 12, also in Portland, Oregon. So this is 8 stories of mass timber, and we'll see some interior images in a moment. This is sort of the precedent that we are chasing in terms of the aesthetics on the interior. This is the current tallest mass timber building in the world. It's in Norway. Please don't ask me to pronounce it, but it's 280 feet. It cheats a little bit because the CTBUH, the Council on Tall Buildings and Urban Habitat, allows architectural elements such as this crown to be included in the building height. That was added during construction so they could go grab the record. And then this is our proposed project in Milwaukee, Wisconsin, Ascent, which is a mixed-use mass timber hybrid tower, total of 25 stories tall, 19 stories of residential, which we will get into, over a 6-story concrete podium. Going back to Carbon 12 briefly, you can see the exposed timber offers a unique aesthetic, which our client found very interesting and appealing. And it's also important to note that the timber is not entirely exposed. In certain places, they drop drywall soffits. That conceals plumbing and electrical and other building infrastructure coming down from the floors above. And just a few examples of the aesthetic qualities of this construction type, again, which is sort of very appealing to our clients.
Yeah, a couple of things that come up immediately when discussing a mass timber project is why. Obviously, there's an aesthetic aspect to it that's pretty much unmatched, which Jason already pointed out, and some of the renderings that you saw already kind of exhibit. But what are the real benefits to building with mass timber? Because there is a cost associated with it. It's not typical construction for what you typically see in this type of high-rise project. Typically you're going to see steel, you're going to see concrete, and we'll talk about a little bit later about what that schedule impacts are. But really one of the big drivers, and you're seeing it, industry-wide and really in all sectors, is sustainability. Making sure that the building materials that you're using are sustainable for the long term. And so one of the big things that mass timber has is it has a sequester ability of carbon. So as you can see, this project alone right now is anticipated to sequester about 7,200 metric tons of carbon, and that's a huge thing for environmental sustainability, and the fact that the resource itself is actually sustainable. It is a resource that is renewable. And one of the things that we had to make sure when we were procuring, when we were doing the research for the suppliers throughout the world, really we researched firms from Japan all the way to Europe and North America. One of the things that had to be done in our pursuit of this was we had to make sure that the forestry that we were getting this material from was harvested in a sustainable fashion, so that everything is replenished and replaced for everything we're taking out. So as you can see, the amount of material that we are going to use for this building between columns, beams, and floors is going to be replaced within approximately 25 minutes within North America, just with regrowth. So that's really important. And that was something that was very important for the developer, and just as the right thing to do with where kind of the world and the industry is headed. So the benefit is significant in that during construction and once this is up, the project will have saved what's the equivalent of 2,400 cars being off of the road for a given year. And that's also equal to the energy to operate 1,100 homes for a year. So that level of energy savings and carbon benefit is substantial and is a real selling point for the developer and our project team in general. Location-wise, as Jason mentioned with some of the renderings before, we are in a urban environment. We are in the heart of downtown, at the corner of Van Buren in the northwest or north-south direction, and Kilbourne in the east-west direction. So that little kind of purple hazed area that you see in the drawing right now is where our site is located. And if we click to the next slide, I think you'll see this is what the building eventually will look like and how it's going to really change the skyline in that area, specifically on Kilbourne. And it's an important thing to note that this is a project that the developer is really his heart's in the right area, because he really wants to see this area redeveloped. There's no TIF, there's no tax money being put into this. Really, it is private development trying to do excellent construction that's sustainable, long lasting, and really driving up the tax base. This is really, if you think about any urban environment, this is kind of the poster child of how development should be in any real Class A city. So a little bit about the project itself. As Jason mentioned, we are 19 stories of timber over a concrete podium. We'll talk a little bit about the sequence of construction and the construction type, but we are approximately 284 feet. We are 259 units, residential apartment units in the building. We do have about 10,000 square feet of commercial space on the first floor as well. And there is quite a bit of amenity space on the 6th floor and on the top level of the building, which is a shared amenity space for those folks that do live here. The timber area is about 225,000 square feet of mass timber floor. That's not the whole square footage of the building. The whole building itself is just under half a million square feet, 500,000 square feet. So it is a significant new build for the city.
So what we benefit from is, again, going back to the two precedent projects, especially the framework project in Portland. At the time, Portland was operating under IBC 2015, which has language in there that basically allows alternative paths to approval through basically performance-based data rather than a prescriptive approach, which is what is sort of in the baseline code. So there is a special section that specifically allows you to pursue alternative construction methodology. So again, going back to our carbon 12 precedent, we have roughly, and we'll see it shortly, we have roughly the same sort of design aesthetic inside the apartments as you saw in carbon 12, where approximately 50% of the ceilings are concealed with drywall soffits, and then the areas in living spaces and bedrooms around the perimeter, they are almost primarily exposed. From a code standpoint, what we needed to prove was that vertical structure needed to survive for 3 hours in a fire, and floors and horizontal structure needs to survive in 2 hours in a fire. No, we'll get to this in a moment, but no wood column had ever been subjected to a 3-hour fire test. And we'll see what that looks like in a few minutes.
As I mentioned before, it's a podium building, and Jason alluded to it, that this is kind of what's required to hit some of the rating requirements. But we from a sequence standpoint, with regard to the construction, we are on deep foundations based on where we're at in the city and what the soil conditions are. We will have driven piles and pile caps for all our foundations in this area, so that's what you can kind of see on the left of the screen. And then we do have our 6 levels of concrete post-tension parking, as well as our core areas, our stairs and our elevator shafts are vertically out of concrete as well. So when we say this is truly a hybrid building, you can kind of see the progression of foundation, deep piles through concrete to the mass timber. And that's a true hybrid construction. And as Jason alluded to, similar to Brock Commons and some of the other projects that have these concrete cores, not only is it a structural element that really is quick and helps with the construction sequencing, it also allows for the egress paths from the highest point of the building to be encased in concrete as a somewhat of a concession to the AHJs, in that they prefer having that concrete stair and egress path. There was a discussion at some points in this of having wood as the vertical shafts for the stairs and elevators, but we kind of quickly went away from that, knowing that it was frankly an easier conversation with the AHJ from an egress standpoint and from a constructability standpoint to get our tower crane through the concrete and then into mass timber. Sequentially, it just made a lot of sense to do it this way.
So we'll talk a little bit about the timeline of this project. Our interaction with the AHJs has been extensive. So our firm was directed by the client, Newland Enterprises, to pursue a mass timber high-rise on this site. They had previously had a 19-story concrete building approved on this site. It was canceled due to the Great Recession. So what we did is we immediately came up with a concept within 60 days from that directive, and then we presented it to the Department of Neighborhood Services Commissioner and the downtown alderman. Because if the Department of Neighborhood Services, this commissioner is appointed by and reports directly to the mayor of Milwaukee, and his department supervises all plan examiners and all building inspectors. In the first of many cases of the stars aligning, we presented this in May of 2018. We learned that the commissioner has a forestry background and was acquainted with the technology and was an enthusiastic supporter. So later that year, he directed his staff to start working with us on trying to figure out a path to approval. So we gave our first presentation to staff, summer of 18. The project was still under wraps at that point. In fall of 2018, we unveiled it at the Council of Tall Buildings and Urban Habitat World Conference in Dubai. Presented that on a Sunday. We thought it went well. We were feeling our oats. We went out for dinner and we got a note from the DNS operations manager that said, Milwaukee Fire Department wants to talk to you. They're concerned. And so the reason that that is significant is that Milwaukee Fire Department does not typically involve itself in the permitting of buildings because the city of Milwaukee has a full-time fire engineer. In this case, they did involve themselves and we were happy to accommodate them. So we'll show you some takeaways from our first meeting with the fire department shortly. Next meetings, again, with DNS staff, wherein they directed us on how they wanted us to pursue a path to approval, which was basically as a type 4 building or heavy timber building with certain variances. And late in that year, again, going back to the performance-based design criteria, we did witness what we believe is the world's first series of 3-hour fire tests that was performed for us by the Forest Products Lab in Madison, Wisconsin. They are a department of the U.S. Department of Agriculture. So they performed the tests for us. And then if they haven't published their findings, I believe they already have, but they will be. We finally had a final variance meeting with DNS staff early this year and filed our variances. And we are currently working through the variance approval letters and a footings and foundations permit. So, and I didn't update this slide. We do hope to break ground in August. Our meeting with the fire department came on the heels of an event that was unique to Milwaukee, a tragedy now. Fortunately, they're rebuilding this, but in 2018, the historic Trinity Church on the west side of downtown Milwaukee was subject to a 4-alarm fire. And basically what we learned when we met with the fire department is that the 2 chiefs that we met with were actively there fighting this fire. And if you look at the image on the lower left, you will see that the only system that really didn't fail was the mass timber roof trusses. Every other system failed to one level or another. After the fire, you can see on the right, MFD took a few of these timber beams and cut them to see how they performed. And they do perform exactly as the code prescribed. They actually performed a little better. So you can see they char on the exterior layer of the timber. The char impedes the flow of oxygen into the structural heart of the member and basically self-extinguishes the fire. That's especially relevant in multifamily buildings where each unit is its own compartment, effectively, separated from corridors and adjacent structure by rated assemblies. So we visited Madison for the 4th of 9 fire tests. So this is the Forest Products Lab's furnace wherein they conducted the 3-hour fire test. That's the furnace on the left. On the right, you can see a glulam sample. The methodology is that they saw the sample in half. If you look carefully, you can see sensors are placed at various depths in the member. They then glue it back together and they put it in the furnace and they burn it for 3 hours. And so on the left is an image actually taken into the burn chamber of the furnace while they're conducting the burn. On the right are the 3 samples they had burned prior, 3 different species, and they all performed almost identically. So what they do, if you look carefully at the image on the right, is they then cut the remnants of the member into sections and see if enough structural material is left to support it after being burned for 3 hours. And what they learned is that the answer was yes.
One of the things that Jason mentioned before when he was talking through some of the renderings is how within the building, the objective is to expose as much mass timber as you can for aesthetic purposes. However, there are some utility functions that you still have to accommodate for. And what those utility functions actually allow you to do is analyze the structure and try to find some cost benefit in reducing the amount of fiber that you are getting and thicknesses of the fiber within the columns, the beams, and the floor slabs to lower the cost in those particular areas and then allow for more exposed areas. So one of the analyses that we've done, as you can see on the picture on the left, is we've laid out where we're going to have dropped ceilings for mechanical and MEP infrastructures. And then that lays out against what's actually going to be exposed. It doesn't change the fact that the entire structure of the floor, beams and columns and floor slabs are made out of wood, but what it does is it changes the thickness of each of those members within a specific area to reduce cost. So the darker gray that you see on the left is actually areas where ceilings are dropped and encapsulated with drywall. So drywall framing or drywall encapsulated timber won't be, the mass timber won't be exposed. It'll be encapsulated by drywall, either by drop ceiling, frame ceiling, or by drywall. And then the lighter side that you see is the actual exposed timber, where you're going to have the exposed columns, exposed beams. And again, this is it serves 2 functions. We have to have those mechanical spaces and those drops to run ductwork, run piping, run plumbing, all those things. But it also allows us to reduce the amount of timber that you have in those areas because we're actually getting an additional rating from the drywall system. So instead of encapsulating everything, we're encapsulating as little as possible, but really using those mechanical areas and maximizing those spaces to serve as dual functions, in that it's less cost from a wood standpoint, and we have to have those spaces anyway. So you kind of see the juxtaposition in that ceiling plan on the left. And then, and that really allows us to have that cost benefit that the owner is trying to seek throughout the project.
Yeah.
And then, go ahead, Jason.
Oh, the other reason for encapsulation of where we have columns and beams that divide one unit from another, because this is a luxury offering, sound transmission was a concern. So the additional layers of drywall help with the sound transmission between the apartments. So that's just another benefit of this hybrid system.
One of the big drivers for cost, and as I mentioned before, in kind of having areas that are concealed, and then you have those areas that are exposed as it relates to columns and beams and where they connect, is the connection point. The connection details are so much more intense when you have exposed beams and columns, and those have to be assembled properly, and they have to have a special UL rating, and they have to be tested multiple times over. But when you have these areas where you have concealed connections, you can see that in this particular detail, it's a very simple connection. The beams are loaded onto the column. There's a simple bolt connection through. Same with the floor slab, comes and it loads down, and it's very, very simple. This is a connection point where we are going to conceal and wrap the beams and the columns and the floor slab with drywall. And that's how simple the connection detail is in those areas. Now, if we click to the next slide, you'll see the detail where it's exposed is extremely more intricate. The assembly and the complexity of this connection detail is vastly more complex. It's more costly. Everything about it screams money, right? I mean, you can just see it by looking at the two different details, and that's the difference. Where we have exposed areas of beams and columns and slabs all being connected together as you do in this detail, that connection has to be very, very specific and UL detailed out, and it has to be all done ahead of time. And so that's what you're seeing in these two different details. The first detail was very simple. It's wrapped in drywall, it's inexpensive, and it goes fast. This detail you're seeing here is something that's very complex, has to have all of those assemblies put together ahead of time, because this is exposed. This is where you're just looking up and you're seeing timber. You don't want to see the connections. They're all concealed, they're all hidden, but they have to be able to make those fire ratings.
So I would add this, if we go back one, look carefully at how much smaller the column coming into the underside of the beams are. That's because those heavy dash lines indicate the 3 layers of drywall on either side. So the fiber or the timber material, as Adam mentioned, is in the columns and beams is extremely expensive, and the connection here is far more complex. But it should be pointed out, I had mentioned we needed 3 tests. The reason we use this connection is that this connection has to be rated for 2 hours in a fire. And this is what they were using at that framework project I referenced earlier in Portland. So at the end of the day, we used the connection that had already been tested. And just as an aside, the 3rd test was specific to the manufacture of the cross-laminated timber slabs. That was just because the supplier had not had their product tested per US standard. They did complete that test in San Antonio in March, and it did pass. So the 3 fire tests that were required, we did 2, or the team did 2, and 1 was a prior approved connection. And then the other thing we had to look at very carefully is, in a high-rise residential building, how does this interact with the skin of the building as opposed to a concrete building? And what we found at the end of the day was it's largely the same from a detailing standpoint. One major change is that we had to be very careful about waterproofing the ends of the slabs in particular, because every other layer, its end grain is exposed. So they are sealed in the factory, but we have an extra layer of waterproofing at the end grain in particular. But other than that, what we've basically found is that this details out much like a traditional post-tension concrete building.
Yeah, Jason, one really good point on that too is that as the building's going up, that's one of the biggest concern, obviously, is the water as it gets on the wood. So as part of the overall assembly of this, we actually have specific carpenters assigned to sealing the seams as the floor slabs are going up, so that there's a roof mastic and basically a roofing compound that's going over every seam as soon as they're being installed, so that no water can then leak down, because that if the water would ever leak down and then stain the underside of that CLT floor deck, to the repair cost for that is significant. So having workers that are truly dedicated to literally water vacuuming and sealing every seam immediately as the floors are assembled is something that's very critical. And as Jason mentioned, as well as sealing the ends of the slabs on every floor. But really, when it comes to an assembly standpoint, the amount of workers that are up on any given floor is substantially reduced in mass timber construction, because it, for lack of a better description, it is tinker toys. As Jason likes to say, you get up there and you whack it with a mallet, a rubber mallet, and the things go together. And it sounds really, really simple, but it actually is. You can see it in the picture to the right. The carpenter is literally just sliding a beam onto the connection, and it is pretty much that simple. And the amount of workers that we're going to have up on any given floor slab is going to be somewhere between 10 and 14, and that includes the workers that are doing the floor sealing and the roof mastic, as I mentioned before. So you have 10 to 14. In a normal concrete frame scenario, on a poor day, you would have anywhere from 30 to 45 workers up on that slab. So the difference in labor cost and, frankly, the amount of people up on that deck and the safety concerns associated with it is significantly less than you would have in a traditional post-tension buildings that you would see in a lot of this type of construction. So the safety standpoint and the constructability standpoint and the number of workers that are required is very much reduced in this analysis. So it's a really kind of interesting nuance to this type of construction that we learned as we were going through it. From a schedule and a sequencing standpoint, it's actually very similar in that the cycle of a floor, our wood floors are about 24,000 square feet per floor. That cycle will be about a 6-day cycle. We'll be able to get a 24,000 square foot floor done in 6 days, take a day off, then go to the next floor. So literally every 6 days, we're able to cycle through a floor. In a normal concrete building like this, it would probably be in that 8 to 10 day range. So it's very similar to concrete, but we'd probably pick up a day every week or so, plus or minus. And over the course of 19 floors, that adds up to schedule savings as well, which again helps offset the premium cost of the timber, because it is a more expensive material and the connections are more detailed and more challenging. So all of that, the manpower savings and the schedule savings, helps offset some of the cost that is the material premium that you see for the mass timber. As mentioned before, this is an example of exactly that kind of hybrid construction. You can see at the lower floor, it's a concrete podium with the mass timber floors going up and those concrete stair shafts and towers going up. This is let's just say a very small example of what you'll likely see in the Milwaukee skyline about this time next year. So this is a perfect kind of picture of what we can expect and how the sequence of materials will be. But the tower crane at this point on this picture, very similar to our project, is fully dedicated to the timber construction. And so really that's kind of how the sequence goes. The concrete gets done, the towers get done, then the wood goes, and that tower crane is purely dedicated to each of those tasks at any given time.
So as we start to wrap up, going back to the aesthetics, so these are brand new images based on the final construction documents. As I think Adam mentioned, we have a 7th floor amenity area, including some fitness. And so here, as wherever else we have timber, we expose as much of it as we can. And then a different shot in that fitness room, you can see we are concealing mechanicals in these drywall soffit areas. In this case, we have apartments above this space, so we have plumbing coming down through there, and it's snaking its way through. And then on the 25th floor, which is all amenity, we again expose as much as we can, and then we achieve a very tall western wall with timber going all the way up, and the ceiling slab is exposed. And we hope to light it up at night and make it a bit of a beacon. So again, another shot of that 25th floor amenity level and the aesthetics of the space that the team has put together. Sorry, a little faster. The aesthetics of the space that the team put together to achieve what we think is a totally unique offering. And then this would be the northwest corner of that space. So panoramic views, 20-foot tall glass walls, exposed timber. We don't think there's anything like it in the world. And then here's a slightly older shot, but again, the aesthetic inside one of the dwelling units. This is the southeast corner of the building. So obviously Lake Michigan views, exposed timber around the perimeter as we've discussed. And then if you look very carefully off to the left, you can see a little bit of drywall appearing above the kitchen, as it will. And with that, that's our presentation. Thank you.
Guys, thanks a lot. That's really interesting stuff. I can't, you guys have put in a ton of work, and what's really fascinating to me is that, you guys benefited from some of the testing work that was done for some smaller projects, and you guys are really kind of at the forefront of setting a baseline that will be used for years to come as mass timber, becomes more and more adopted in construction. So fascinating stuff. I can't wait to see the start of the work on this. And then next year, maybe around this time, a little bit later, enjoy the 25th floor with both of you guys after we see things lit up.
Great.
Absolutely.
Okay, great.
Well, thanks for your time, guys. I really appreciate it. And we'll look forward to an update. Take care.
Thank you.
Thanks much, Eric. Take care.
Thanks.
Sweet. That was really good.